bounds.
Hello guys, this is Hacks Pranks and I'm your host Maheshwaran. Today we are going to teach a very interesting topic which is nothing but differential calculus. Of course, when you get into this level you would have heard this term in physics and I don't think probably you would have understood it, neither me. The first time and I had to consult upon my friends and so many to get it into it. So let's get started. So first, simple. You need to understand this term in simple terms. Okay. So first let's consider a small box, an object with mass, too many masses. Okay. Particle and point masses together combine to form a total mass, a mass object. Consider the ground to be here. Since it is from a height, since it is in a height, it contains potential energy, as you guys know. We shall not get into energy now, but still it contains potential energy. As it comes down slowly, it changes to zero, right? Zero potential energy. So let's assume, and acceleration due to gravity, we assume it to be 9.8 meter per second square. Okay, so first let's assume that this object of in height h takes 3 seconds to come to the ground. 3 seconds to come to the ground. So if I ask you, like I'm a scientist, I'm observing everything, physicist, I observe everything. I'm asking you guys a question. At correctly 2.1 seconds, what would be the position of this object? Right. So it's simple. So you will find, if you know this value of h, you would be finding the the height of the thing, or you have the acceleration given, so you would find the velocity of this object falling down. Then what you would do is multiply it with the given time to obtain the distance, right? Okay, so that would be easier. But suppose there's another kid. He's a more more crazier and a nerd than me, and he's like 2.156 seconds, and he wants you to know the position of the object. Of course you can use it again, but this is not possible always. This you can't be measuring with even a normal clock, and you use the formula and stuff and to find it. So this is easier for this, but in complicated cases this system will not help you easily. You need to do simple things, right? Then only you can be focused and concentrated. So this differential calculus helps in this. Instantaneous velocity of an object. Okay, let's first you understand the term differentiation. Let me give you a square. Assume it to be a square of side 3 centimeter. If I ask you to find its area, what would you do? You would just square it and get the area as 9 centimeter square, right? But suppose I give you an arbitrary shape. Arbitrary is nothing but it doesn't have a definite shape. Okay, let's name it as Mahesh shape or whatever you want. Okay, then if I ask you to find its area, what would you do? What would you do? Basically this was a square, you know it has definite shape, you found the area. But this one, how do you find it? Think of it. Pause the video and think of it. So the answer is simple. You either place it on a graph paper or you divide it into equal segments. Right. This isn't that very equal, but assuming it to be equal. Okay, equally you divide it and you get the object here, right? Here's your object. So what you do, you have small squares in between. You just find the area of those small squares and add up, and here you like approx triangles. If you follow and you add up all this and you get this area, but this is actually approximate, you only get the approximate area, but though you get it accurate, somewhat accurate, rather than finding no area of an arbitrary object, finding at least the approximate accurate area is worth, right? So when I divided this object, that is differentiation. That is what you have to know. Okay, and when I'm adding up all the small area to obtain the total area, that's integration. Simple. In simple words you can know this. So that's what I wanted to say. Let's prove this in a graphical way. Let's draw a velocity graph, which is nothing but, here will be the x-axis and the x-axis and y-axis, and time being the independent factor here, I write it in the x-axis, and distance being the dependent factor here on time, I write it on the y-axis. So time is independent, right? It doesn't stop for someone or fast forwards for someone. It is constant throughout. I have it as the independent quantity here, and with respect to time, the object changes its position. So let's draw a graph. Okay. So basically, this isn't what to say. This isn't the speed graph. You get it? This isn't speed basically. Okay. This line is not speed. Then what is speed? It is nothing but the angle of inclination. Let's assume this to be point P. The angle of inclination of the graph with respect to x-axis, which is nothing but the slope, and which is nothing but so-called velocity. Okay, you get it, guys? So it's distance or displacement, whatever you have it as speed or velocity, I don't care. Whatever graph it is, the laws are the same. Okay, so this is theta, fine. You have it as the displacement on time graph, which is nothing but the velocity graph. Okay, so suppose I ask you to find the velocity of the object here in Q. So what would you basically do? That's a big question, right? Seriously. So the velocity would be nothing but tan theta. How is that? How would you find velocity? Which is nothing but displacement. You call it as yes, right? Displacement by time. So here the displacement from P, considering from P, what is the velocity in Q? So considering it this to be, what is this? Distance traveled from this point to here. Okay. Then this is the, you put it as yes, right? Displacement. Okay. And this is time. Speed by time will give you velocity. Which, what is speed by time here? This is opposite by adjacent for this theta. What is that? Opposite by adjacent. What do you call it as? Which is nothing but tan theta. So you get the slope, which is nothing but the velocity. Now you understand it, guys. And now how differentiation works here, I'll do it in my next video. Thank you for watching this till here. Thank you.